There is a shift in the speakers, and so we'll have in fact, third speaker uh, having her speech just now.
Um, yes, ladies and gentlemen, esteemed colleagues, it's my honor to introduce Engineer Khalikova, a dedicated professional with a focus on fire safety in concrete structures, with a keen interest in ensuring the resilience of built environment. Uh, she brings her expertise in fire codes and regulations governing concrete structures. Her insights into fire-resistant construction methodologies are vital for safeguarding lives and property. Unfortunately, we are not able to have her in person. We were eager to meet her here due to some travel, problems with her travel. She's not able to be with us here today in person, but fortunately, we have made a video conference call, and please put your hands together for Mrs. Khalikova as we see her through the conference call.
Well, good afternoon, everybody. Thank you all for generously giving us your time, especially the esteemed professors present in this conference. Well, I also want to express my special thanks to dear Professor Khalu, who is also my PhD advisor, for creating such a valuable opportunity for all of us. Well, my PhD journey is going on the field of structural fire engineering. And so we decided to investigate the fire regulations in different building codes. It is worth mentioning that Russian Federation has its very own independent vision on engineering with building codes labeled as SP. For example, we have SP 63 for reinforced concrete structures, we have SP 16 for steel structures, and so on. Well, long story short, I have asked my friend Miss Diana Khalikova from Russian Federation to join us in this meeting and present a brief introduction on fire safety regulations in Russian codes. Okay. Диана, нас слышно?
Да, вас слышно, а меня слышно?
Хорошо, давайте начнем, пожалуйста, по-английски.
Okay. Good afternoon, dear guests and conference participants. I apologize in advance for possible interruptions in communication since I'm connecting to you from Russia. Today, I'm glad to present you a report of our common work with my Iranian colleagues, Zainab Megdadi and Mohammad Shabanlu, fire resistance of concrete structures per Russian code. Now I want to starting share my screen and please 1 minute. Okay. Can you see my screen?
Yeah, we can see your screen, but please use maximum presentation.
Yes. Can you see my screen now?
Yeah, I see your screen completely. Thank you.
Okay. Different design codes such as ACI, Eurocode, and SP face this subject with different approaches. In some cases, the minimum thickness of cover is determined using prescriptive tables, and some others have a calculation-based method. This study focuses on determination of minimum concrete cover thickness for flexible members based on calculation-based approach of Russian code. Okay, at first, fire rating of the structure is the period of time state normalized for this structure. States that characterize the onset of loss of bearing capacity are loss of reinforced concrete structure R occurs due to a decrease in the strength characteristics of reinforcement and concrete when exposed to fire. Calculation of a resistance limit of reinforced concrete structures based on laws of bearing capacity consists of thermal and static parts. Um, Thermal parts are carried out for a given file duration. In the thermal engineering part of the calculation, the heating temperatures of concrete and reinforcement along the cross-section of reinforced concrete structure are determined for a given duration of the standard temperature pattern in order to determine the coefficient of the operating conditions of reinforcement and concrete during heating. And static parts strength of the heated structure is calculated taking into account changes in the properties of concrete and reinforcement due to temperature influences and the specifics of whatever pattern is in. In general, the fire resistance limit for loss of bearing capacity R is ensured is the following condition. Condition shown
Yes, yes, we see your cursor.
and left part is standard longitudinal force of or bending moment from an external load, constant and temporal long term. And right part is a load bearing capacity strength or reinforced concrete structure during a fire with a duration equal to the R value. Design and standard values of reinforcement resistance to tension and compression under high temperature impacts RSMT, IST, RSST are determined by multiplication of reduction factor of gamma ST on standard and design values of these meanings under normal conditions accepted according to SP63. These coefficients, gamma ST, are determined experimentally for reinforcement of each type. Example for our reinforcement you can see in the slide. Coefficient values of operating conditions of concrete to determine are PNT except equal 1 in this calculation. The heating temperatures of concrete and reinforcement along the cross-section of a reinforced concrete structure are determined by isotherms, which are given in SP 468. During a fire, beams are usually subjected to three-sided heating, the bottom part and the two surfaces part. Heating of the tensile and compressed reinforcements occurs as well as the concrete of the compressed zone, the zone shown in the figure. The failure of beams occurs due to the formation of a plastic hinge. When accessing the fire resistance limit based on the loss of bearing capacity of a simply supported beam of rectangular cross-section is determined with using these formulas. And this. AT is the depth of heating to the critical temperature of heavy concrete in a beam from the heated phase of the section under the influence of a standard fire temperature pattern. It is determined by these terms. Following the calculation method can be used for beams with different dimensions based on requirements fire. In this table, we can see concrete cover for structures taking into account standard fire and the dimensions shown for center of main reinforcement in beam. In an investigation by panel, it's observed that the temperature duration increases in a free-phase exposed flexible member. The temperature gradient goes through a section which complies with AT German Russian Code of Engineering Practice. You can see. Its conclusion. This study investigates the calculation-based approach of Russian Code of Engineering Practice, SP 468, for determination of concrete cover thickness in free-side fire exposed concrete structure members. The conclusion can be drawn from this study. Russian code can precisely capture the temperature gradient in fire exposed reinforced concrete members. Experimental studies in literature show similar temperature gradient, same as the Russian code approach. A table presented to determine cover thickness based on Russian code for beam sections with different fire ratings. Thank you for your attention. Всё. Надеюсь, меня было хорошо слышно.
Thank you, dear Diana. Any questions? We have time for one or two questions, I think.
Yeah.
Okay, Dina, there seems there are no special questions. Thank you for your great presentation.
Okay, I need to disconnect. Рихана, мне нужно включиться или... Sorry, I can't hear you.